we've got Anna Kartashova, who will be talking to us about estimates of parameters of selected meteor streams. And you also have 14 minutes total.
Good afternoon. And I'm continuing to talk about the meteor streams. And as you know, day by day, the small particles enter to the Earth atmosphere. Some of them can be danger to the human life, but some can be danger for the work of spacecraft and space telescopes. And all information about these small meteoroids we can get from their entry to the Earth, to the atmosphere observations. Various optical systems used for meteor multi-stations observations, and all of them have limits at the observations. And in this presentation, I will talk about the observation database of Global Meteor Network and IMO Video Meteor Network data and some Sanataka data. Optical meteor observations permit to obtain the parameters of the meteoroids, which are necessary for studies of dynamic and physical characteristics of meteor showers, as well as sporadic background. Various of effects can be found from the individual parameters of the meteors. Using the individual parameters of meteors, we can analyze the meteor showers. Most important to estimate how meteor particles are distributed by mass in the stream, and as well as we want to know how these particles are distributed along orbits and what mass they have. How we can compare observation data with the models. We are working at the model of mass estimations for small meteor particles, and we compare our results with observations data. So we are interested how mass estimated by observations data and how various assumptions and approaches influence to mass values. And then I will talk about mass and index mass for some meteor showers. For mass estimation, are using of the meteor's parameters like the magnitude, velocity, and others, and like curves. To take approach of mass estimations, photometric and empirical masses look that. And from the other side, the mass index is used to study the properties of meteor shower. It characterizes the distribution of meteoroid bodies by mass in the shower, and the distribution of meteoroid masses is described by the law. We analyze 3 meteor showers like Perseids meteor showers, Geminid meteor shower, and Arianids. We took 2 approaches of mass estimation for same observations data from Global Meteor Network database, and you can see the different and the S values in the sum part of the curve activity, profile activity is the S values is closest, but in the sum part is not very close. But if we compare this data with the IMO observations, you can see that the S values are closest to this distribution too. In the same situation, you can see for the other years. Only in 2019, S values are not S values from Global Meteor Network not similar to IMO data, but in the other years, this mass index values are closest. But if we look, I hope that you can see, but if you compare with the Sanataka data, it's the red dot here and here. We can see the difference in the mass index distribution. But according to our estimations and by both mass estimations approaches and other authors, the S values are closest to 2. Okay, the same analysis was carried out for GMN meteor shower, and you can see that the S values closest to 2, and S values to depend from mass estimations. Distribution index, mass index by Sanataka data and global meteor network data in some years are closest, but in the some years are not. But average S values are closest to the 2. But if you look at the meteoroid Arianid meteor shower, we cannot see the same situation. We can see that the distribution of S values are very different and variated from data to data, from year to year, and the S values ranges. I think that's too large, and you can see here. And as I think that the S values should be closest to the 2. But okay, in the conclusion, the calculation mass index different for different methods of determining of mass of a meteoroid. The difference in the mass index values can depend on the calculation of velocity, magnitude, and other parameters. It can also depend on the observational data itself. And the values in S estimated can reach 1.7 times. We will investigate what influenced the difference in the mass index values so much, but in any case, we should take into account approaches of the mass estimations in our investigations. Okay, thank you for your attention.
Right, do we have questions for Anna? Anybody in the room or online? Ask a question. So what do you think is the next step for your work, the next project on this?
I think that first of all, we should understand what's happened with the data for Oraniid meteors, and I think we continue to look at this distribution for the other years, because we need to compare all results and understood what the difference between these methods and how we can use this difference. As well, we are using our meteor optical data because we needed the light curves for each meteors, for photometric mass estimations and for our models. Okay, and we try to take into account all observation data, all type of observation data.
All right, is there any more question? Oh, Galina's got a question. Go for it, Galina.
Yes, thank you. It is not maybe the question, but comment. You mentioned that Oraniid S is different from year to year, but it could be related to many from many revolution, ejection from many cometary revolution. In my opinion, Gemini stream was originated from only one revolution, but for sure, Halley comet feed the stream for many years. And any year, you should know which kind of perihelion made this shower. It is very difficult task. Thank you.
In AreaNet meteor shower, I mean that for one observation data, we have very different
Yes.
values of S. You can see
Yes.
here. Yes, okay.
And probably they all have different ages.
Okay, okay. We continue our work. Thank you.
All right, let's thank Anna again.
Mhm.